Hello, this is day 2 homework for distributions. We are talking about and reviewing center, shape, and spread. We're going to be looking at a bunch of histograms as well as a dot plot. Starting off, number 1, for each of the following histograms, describe the shape and give estimates of the mean of the distributions. So for A, this one's approximately symmetric. As you can see, it has 6 bars and it's a little bit more kind of stretched to the right, but it does have a pretty nice bell shape. So we're going to call it approximately symmetric because it's not exact. The middle in symmetric data is the best measure of central tendency, and it's X bar, which is the mean. So we're going to say this one is about 560. Looking at B, all right, for this one is a little bit not as symmetric, a little more skewed to the right with the extra bar. So because of that, the mean is going to kind of stretch to the right. So the middle in this case is about 19,000. However, because it's a little bit stretched to the right, it's going to increase, and I put 19,400. You could have had 19,500, 600, so somewhere in between 19,000 and 19,600. Number 2, we're matching with the best histogram and the description. So for A is going to be in the bottom right corner. For this one, the data is approximately symmetric. It's obviously not exact. The mean is in the middle, which is 50, and it's going up by about 5 units. B is going to be the one right here. This one is approximately symmetric as well. There's a mean of 50, so about the middle. And then a standard deviation is going up by about 10 units. For C, the mean, all right here. This one is approximately symmetric. The mean in the middle is about 30, and the standard deviation is 10. And for D, this one is very close to being symmetric, still approximate because not exact. Has a mean of 30 and going up by about 5 units. On the back, okay, we have following are the numbers of calories in a basic hamburger. 1 meat patty with no cheese at a sampling or fast food restaurant around the country. So those are all the calories. So I plotted these on the dot plot, approximate, not exact. And for this one, it then says, B, describe the shape. This one is approximately symmetric. Our data has a decent amount of points in the middle, and it kind of spreads out to the left and the right. It's not exact, but approximately symmetric. Now we're going to use our calculator again, our stat application, to plug these in. So when you do that, once again, you would use the stat button, and you would go to edit, and you would type in the values into L1 or L2, whatever you prefer. If you have nothing else there, I'd plug into L1. You then push stat again in calc, and you would get the mean standard deviation. Now, our mean is 665.3, and our sample standard deviation this time, we're using the sample because this is obviously not all the hamburgers throughout the entire country. All right, this is a sample. So we use, and it says sampling, so we use S sub x and get 283.4. For D, it says, what percentage of data is within 1 standard deviation? So if you take a look here, you can use this type of style for all the questions. So 1 standard deviation above, you would be adding the standard deviation of 283.4 to 665.3. That would be in the middle. I'm actually going to write that in right now. This is where the mean would be, 665.3. That's your mean. And then you add 1 standard deviation, subtract. And then finding out how many values fit in there. So I did that right here. There were 20 out of a possible 32. And to convert that to a percent, that would be about 62.5%. Within 2 standard deviations, so you do the same thing, just add 1 more standard deviation to 1,232.1, and also subtract another one. And they actually all fell in between there. So it was a 100%. So therefore, if all of them fall within 2 standard deviations, then all of them are going to fall within 3. If you wanted to add a third standard deviation and subtract a third, you could do that as well. E, why do you think there is a lot of variability in the calories data? Well, not all hamburgers are the same. Whether you go to McDonald's or Burger King or Wendy's or Five Guys, the burger size is different. Bun size could be different, and various condiments you put on. So that's going to give you a different caloric intake. Now we're going to take a look at the bottom. So given the information, find shape, mean, standard deviation. And obviously these are approximations. So the first one we have, and it looks like it's going to be kind of symmetric here, but it has a tail, so it's skewed to the left. So because it's skewed to the left, the middle, which generally would be here, is going to move over to the left. So I had about 203. You also could have had like 200, 205. It's once again just an approximate. The standard deviation, how the bar is changing. The standard deviation, I have about 5. You also could have had about 10 as well. So somewhere in between there. Looking at this one. So now this one is skewed now to the right. The middle, therefore, is a little bit to the right. I had about 35.5. You could have had a 35, 36. Actually, more so 35 and 35.5. Could have been 34.75. So somewhere in that area right in here. Standard deviation is going up by about 1. Down here, it's approximately symmetric. So therefore, our mean is in the middle. It's about 74. The data is kind of being pulled to the right. So I have my standard deviation by about 6. And last but not least, this one is skewed right, kind of getting pulled to the right side. So therefore, the middle is being pulled a little bit to about 8. All right, so in this area right here, and the standard deviation is about 4. Now, once again, these values are approximates. They're not exact. So if you're off by a few, or 1 or 2, that is okay. On a state test, they probably would give you a question where it would tell you, what do you think it could be? And you'd have to get the closest value. Thank you.